Okay, so I showed you how to multiply from the paragraphs instead of using the two-way tables for the independent and dependent events. So today's focus is going to be only on those independent events. All right, so at the very, very top, right, we're determining if the events are independent. So that formula that we saw yesterday said probability of A and B equals the probability of A times the probability of B. So essentially what we're going to be doing is multiplying these two events together, and we're going to verify if it equals the and. All right, so here's what I mean. We've got events A and B. A is 0.2 and B is 0.4. A and B is 0.6. So if we plug it into this formula right here, the and is 0.6. I'm going to put an equal sign with a question mark over it. A is 0.2 times B. B is 0.4. All right, so we're verifying, does this product equal the and, which was 0.6? All right, so 0.2 times 0.4, I'm pretty sure is not going to be 0.6. Nope, it is 0.08. So we have 0.6 does not equal 0.08. Since they don't equal each other, we would say they are not independent. All right, they are not independent. All right, let's check out the next one. We've got C is 5/8, D is 3/8, C and D is 15 out of 64. So following the formula, the and is 15 out of 64. And I'm going to put a little question mark because we're seeing if it equals. Then we multiply these two events together. So 5/8 and 3/8. 5/8, 3/8. All right. So 5 times 3 is 15. 8 times 8 is 64. So this does equal 15 out of 64. So big old check mark. Yay, it works. So for this one, we would say yes. It's independent. All right. Let's get into a table. Ooh. Looks like we need to get some totals real quick. Total. Ooh, this blue marker's starting to die. No. All right, so we have a total of 13, 17. 17 plus 13 is 30. So that's going to be my denominator. Going this way, 12 plus 3 is 15. 1 plus 14 is 15, and that totals 30. Okay, so we want to verify if the events studying, so here's studied, and scoring 90 or higher, so greater than 90. We want to verify if those two events are independent. Okay, so let's start with the intersection, right? The and. This is the intersection. All right, so the intersection is 12 out of 30. And we're going to put a little question mark. We're going to verify if it equals the product of these two events. So studying was 15 out of 30. Scoring greater than 90 is 13 out of 30. Notice the denominator is 30 all the way through, right? Whatever the grand total is, we use that. Okay, so good old calculator to the rescue. We've got 15 over 30 times 13 over 30. So this is equaling 13 out of 60. And over here, I don't think that's going to work. Let's reduce that though, because I bet it does. 12 out of 30. 12 out of 30 reduces to 2/5. And if you don't have a calculator that has the fancy fraction button, you can turn them into decimals. That's fine. Anywho, these two do not equal out. All right, since they don't equal out, we would say, nope, not independent. So the event studying and scoring 90 or higher is not independent. They depend on each other. All right, next up, we need to get some totals. Nope, totals are done. Yay! Okay, so here's that grand total. All right, so the events are being in the 12th grade, and doing community service. Does community service. All right, so the intersection is 16. So we have 16 out of 60. All right, so let's verify. Let's see if this intersection equals the product of these two events. So 12th graders were 24 out of 60 times community service, 40 out of 60. All right, so we've got 24 out of 60 times 40 out of 60. I'm going to do decimals this time since some of you might have decimals at home. Okay, so when you multiply these two fractions together, you get the decimal 26666. I'll round it. And then 16 out of 60. That decimal, oh yay, it matches. Look at that. So I'll put a check mark. Since the product of the two events does equal the intersection, we say yes, they are independent. All right, let's try two more. Events being in the 10th grade, okay. And preferring dogs, all right. Okay, so the intersection is 16 out of 110 for the grand total. And we're gonna verify to see if 10th graders, so that's 20 out of 110, times dogs, 88 out of 110. So we're gonna see if this product of the two events equals the intersection. All right, here we go. 16 out of 110, let's go ahead and convert that guy. So this decimal is 145. All right, and then over here we have 20 out of 110 times 88 out of 110. That gives me, oh, look at that, it matches. 145. Check. So we are independent. Hopefully you're getting the idea with this formula. It's the same thing over and over and over. Okay, so are the events being a boy and being a stage crew member independent? We need some totals. Such a weird word, total. Say it over and over. It starts to sound weird. Total, 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 total. What? Total. All right, so 14 plus 21, we have 35 performers. 18 plus 7, that's 25, right? 18, 19, 20, 21, 22, 23, 24, yeah. So then 35 plus 25 is 60. Okay, and then going this way, 8, 9, 10, 11, 12, so that's 32. And 28, let me make sure that adds up to 60. Yep, all right. So here we go. We want the events being a boy, 32 boys, and being a stage crew member, stage crew. Okay, so the intersection of these two events is 18 out of 60. All right, and let's verify. So the event being a boy is 32 out of 60. The event of being a stage crew hand is 25 out of 60. All right, verify. Boom, we've got 18 out of 60. That decimal is 0.3. Over here, we've got 32 out of 60 times 25 out of 60, which is 0.2222222222222. These do not equal each other. So no, they are not independent events. So being a boy and being a stage crew worker, they depend on each other. They are not independent. And that's the end of today's lesson. So take a picture, send it to me on Edmodo so I can throw some points your way.